చెన్నైలోనా? దానికి ఏదైనా గమనికి రాదు కదా. చదివాడు Bhupati sir, good morning.
Good morning, sir. How are you?
Fine, sir. Please start your video.
Yeah, got it, sir. Oh, something, it's not it's having some problem. I think so the video has some problems, sir.
Okay, okay.
No, I don't know why it's having some problem.
Okay, sir. Shall we start, sir?
Sorry, sir. Video has some problem. I don't know what happened.
Okay, sir. Are you able to share, sir?
Yes, sir. Yes, sir.
Okay.
Yes, sir. You can start, sir. You can give introduction and you can start now.
Okay, sir. So, good morning to all of you. I welcome you all for the today's session by K. Bhupati, Director and Division Head, Research and Development, and Resource Data Analytics and Forecasting and Solar Radiation Resource Assessment from National Institute of Indian Energy, Chennai. So, sir is going to give the topic on wind energy technology application and trends. So, before handovering the session to the Bhupati sir, let me introduce about the Bhupati sir. So, sir,
yes, both represents the XLG. Okay, so now that XLG is, if you just simplify it further, H minus H naught minus
I think so. Some lecture is going on backside. Ask them to mute it, sir.
వేరే వాళ్ళ So, sir is graduated from mechanical engineering and received a master's degree in energy and M.Tech footwear science and engineering. Currently pursuing a PhD. Sir worked faculty at engineering college at VIT University and then joined in National Institute of Wind Energy in January 2003, dedicated to assess the wind resource potential of India at 50-meter height and successfully published for public. Prosperously lead wind resource assessment unit as head of the department from February 2012 to April 2017 and successfully launched the Nation Wind Power Forecasting Project and received Scotch Award in 2016 and E-Governance Award in 2019, Best Forecasting Award in 2019 and a Merit Order Award for Solar Power Forecasting. Successfully developed 50-meter, 80-meter, 100-meter and 120-meter height wind atlas and published. Providing consultancy for leading government organization, public sectors and private organizations such as wind farm design and development, and involving in various research projects such as offshore wind profile measurement, wind characteristics, study in complex terrain. So looking after R&D, data analytics and forecasting, solar radiation, resource assessment and renewable energy projects. So published various research papers in wind and solar energy. So first of all, congratulations, sir, to you.
Thank you, sir. Thanks a lot, sir.
And also, thanks for accepting our invitation to give an expert talk in this 2-week faculty development program on renewable energy interventions in industry, domestic and commercial applications. Thank you, sir. Over to you.
Thank you, sir. Thanks a lot, sir. Yeah. Sir, whether my screen is sharing?
Yeah, yes, sir.
Hi, Subodhayam. Good morning to all. Can you hear me, sir?
Yeah, hearing, sir.
Yes, sir. So good morning to all. And first of all, I would like to congratulate the team members for organizing such a kind of program. And also, I would like to express my sincere thanks to the management and the head of the department and the sir for inviting me to give lectures on wind energy technology and it. So it gives me great pleasure to be here to give a lecture on this topic. So I hope I will not make you too sleepy and I will not make you too bored. So whatever the things just we have learned, I would like to share my experience in this wind energy. So you may learn, and if you have any question, and please note it down. You can ask at the end of the session or in between, in case if you want, you can raise. But you can I cannot see your raising hand, but you can interfere in between in case if you have any doubts. Right, sir. Yeah. So thank you, Subodhayam. Vanakkam. In Tamil, it is always our traditional to say Vanakkam. So now you know the COVID situation. We are not, shake handing, and we always, we put together our hands, and we say that Namaste, Subodhayam, and Vanakkam. So in Vanakkam in Tamil. So generally we used to say that. So whenever we see the people and always greet Vanakkams, whenever you go to the hotel and any places, they used to say that. Yeah, traditional, we should not forget our traditions, whatever it may be. Even if you go to European and American, they used to say hugging and, touching cheeks and other things. But it is our traditional, it is a fantastic way. So thank you. And yeah, sir, and also I would like to thank sir for giving me about me, for giving the wonderful introduction. So this is about me. Yeah, so currently I'm looking after research and development, data analytics and forecasting, solar radiation resource assessment. And yeah, so this is, I would like to say a few words about our organization. So many of them, they may know that, and many of them, they may not also know that. So National Institute of Wind Energy, which is located in Chennai, Velaseri. And also we have another office in Kayathar, 600 kilometers away from the Chennai, towards Kanyakumari. So many of them know that. So we have the many divisions: wind, solar, offshore measurement. What we do the measurement of at a different height of the wind, and for the solar resource assessment we are doing it, and also the offshore measurement recently we started. And research and development, resource data analytic and forecasting. So we collect all wind resource assessment data, solar resource assessment data, as well as offshore data. We do the analysis and will give the interpretation how much the potential it is there, whether we can install a wind turbine or solar power plant and offshore wind energy at any particular locations. And also we carry out the research and development in application-oriented research and development associated with various colleges, universities, and manufacturers and developers. So doing research and development, and also we do the forecasting. The forecasting, how much the wind power it is going to be there in a particular wind farm, or how much the solar power it is going to be there in the particular wind farm at the same day or the next day, how much it will be there. And the certification of certification information and technology, I mean, before that we do the testing of large wind turbine and as well as the small wind turbine. The testing is being carried out at 600 kilometers away from south. There we have the wind turbine test station. It's in Kayathar, it's a Tirunelveli district. And after doing that test, we carry out the certification and certification for the small and the large wind turbine. And we have the skill development and training divisions. There we give the training for national and international training participants. And standards and regulation, we support to create the standards for the large wind turbine, the small wind turbine, and for the regulation. And solar radiation resource assessment, I told we measure the solar radiation across the country, and we carry out the renewable energy project. We are giving the consultancy for EPC contract project, like 1 megawatt, 2 megawatt project for various universities. So this is about our organization. Yeah, so first we start, what is energy? So energy, that, so without energy, I can't talk to you. Without energy, you can't hear me. So we need always energy. So what is energy? Energy is nothing but it's the capacity of doing work. And the energy, so the first law of thermodynamics, you are the mechanical engineers, you know that first law of thermodynamics, energy, I mean, energy neither can be created nor can destroy, but it can change from one form to another form. So why I have to talk here, because now we are going to talk about that the wind energy, how it is changing from one form of the energy into other form of the energy in terms of the electrical energy. Now just look at these pictures. See, he wants to run, he wants to do cycling, and he wants to do exercise. The airplane has to fly, and the car has to run on the road. So all these things, what you need energy. So without energy, there is no fuel. Will the flight will fly? No, we can't. Whether this person can ride cycle, he cannot do it. So the basic thing is the energy. So we know that energy we are getting from the different sources, like thermal power plant, nuclear power plant, and hydraulic power plant, and also other renewable energy resources. Now we are going to talk about the one of the renewable energy called that the wind energy. So what is a wind? The wind is nothing but it is a motion of air related to the Earth's surface. On it, it's a very calm wind will be there. Other time, it may be the very howling wind speed will be there. I don't know how many of them have heard. In case if we are nearby seashore, just look at this picture, how the wind is blowing. So the wind is coming from this direction, how it is blowing there, the wind. So it means that when you are standing there, you may hear the sound, that the howling sound. So the wind energy, it's a variable generation, variable in nature. Variable nature means it will vary from place to place. Where you are standing here, where I am in Chennai. So it is a Chennai. You are in Hyderabad. The Chennai, it will be the 3 meter per second in the now. At the same time, the Hyderabad, it may have the 4 meter per second. It's a vary from place to place, and also the time. Now you can see the wind speed will be Now it's a 3 meter per second, again it'll go to 5 meter per second, again 2 meter per second, 1 meter per second, again go 20 meter per second, it will go. And you can see the time. So time is, that is at 10:32, 10:33, 10:34. So like this, see that how the wind is, that is a variable nature. It vary from place to place and time to time, and also season to season also. Generally, the windy season means that is a May to September. That is a May to September. So during rainy season in Tamil Nadu, during rainy season, it means that it will start from May and end in September. So wind will vary from place to place, time to time, season to season, and also wind will vary from height to height also. See here now, this is the wind speed, 3 meter per second, 5 meter per second, 8 meter per second, 12, 15, and 20. You can see the wind speed at lower height. This is a 10 meter height, this is a 50 meter height, this is a 100 meter height, this is a 150 meter height, the wind speed. Now look at the figure. Now you see that at 10 meter height, I have the only 4 meter per second. At 50 meter height, I have the 8 meter per second. At 100 meter height, I have 12 meter per second. And 150 meter height, I have the 15 meter per second. So the wind speed will vary from height to height also. This is called, that is the wind shear. That is the wind shear. So now you can see the wind will vary from time to time, place to place, season to season, and height to height also. Just it will vary. So this is the basic characteristics of the wind. Yeah. So what the wind resource, how the wind which is originated. So the wind, how it is originated. The earth which is made up of water surface and the land surface, right? So the land surface, the observation of the heat, the sun. So during the daytime, what is happening there? The sun rays which falls on the surface, okay, earth surface. See the observation of the heat by the water, observation of the heat by the land. So which one it will heat faster? The land. The land will quickly heated and the water will slowly heated. So now when the radiation falls on the surface, above the surface we have the mass of the air which is blowing. So when the sun rays falls on the surface, what will happen? Air will become the heated. So once it's heated, its density will become lower. So the lower density always go up and the higher density air from the water surface will come in. So this is called, that is a sea breeze. During the daytime, we'll get the sea breeze. During the night time, because of the observation, the different observational characteristics of the water and the land, during the daytime, the water surface will emit the heat to the up heat there, and the land will become quickly cool. Now what will happen above the sea surface? The air become, that is the heated, and the density of the air will become lower. So the lower density air will go up, higher density air, because the land becomes, since it's a cooler faster, then the higher density air will come in. This is called, that is a land breeze. During the night time, you will get the land breeze. And also the rotation of the earth, the wind will so moving from one direction to other direction. So this is the way that wind which is originated. The most of the energy which is coming from the sun only. Even nowadays you are using the petrol, diesel product, and this is a petroleum product. How you are getting? And also the coal. So you are burning coal for producing the steam. How you are getting it? Because of the millions of years ago, the wood log that went into the surface of earth, and due to the high pressure and the temperature, and years become, then it become converted into coal. So that coal you are burning it, because the coal has some energy. That is the thermal energy. And also the petroleum product in the sea surface. The many algae are there, algae and animals are there. So after decaying these animals and the plants, then it will go to the surface of the sea, and it will convert it into methane. So this methane, and it becomes that the millions of years, then it will convert it into oil. So now we are digging from the sea surface, right? So that's the way. So what is the wind generation? So wind generation, what are the advantages that, renewable energy compared to thermal power plant? So thermal power plant, whenever you are burning, coals, what will happen? It is emitting the obnoxious gases like carbon dioxide, sulfur dioxide, and the nitrous oxide. And also when when you are burning this kind of gases, it's emitting to the atmosphere. And also, the thermal parameter, you are the mechanical engineers, when you are when you are generating the steam, you need you are the steam has to be condensed. Once the steam has to be condensed, means you need, that is the coolant water. That is the coolant water you are taking from the sea surface, or you are using from the river water. So in this wind generation, you do not need it, and it is indigenous. No need to compete with the rest of the world, and distant from the supplies. And compared to fossil fuels, it's a cost, supply constraint in features. Environmental pollution, there is no environmental pollution, no carbon dioxide emission. The disadvantage is it is a small scale, dispersed. The wind is not in in any particular area only it will be there. Not always everywhere it will be there. And you cannot install wherever you want, wherever the load center is there. We have to install the wind turbine where the wind is there. That is the disadvantages. And compared with the fossil fuel, power supply on demand and economic scale can be done it. Right. The first thing is the resource assessment. What is the resource assessment? How do you assess the resource? Why do you want to assess the resource? Whatever the resource. Suppose if you want to develop your agricultural farm, first thing what you want for developing agriculture farm, you want the water resource. How do you get the water resource? In case if you have the river, if you have the dam, and if you have the lake, you can get it from there. Or else you have to dig into the ground. What you have to do? You have to drill, or you have to dig a well. It means that simply you are going to dig a well, or dig a bore well? No. What you have to do? You will assess. How do you assess? Then you will approach the geologist. The geologist what will do? They, based on the satellite. Hello. Hello. Sir, is there any issue? Hello, is there any issue, sir?
No issue, sir. Somebody on the mic.
Okay, right. Sir, if there is any disturbances, yes, sir. If there is any disturbance, please inform to me, sir. Right. Okay, sir. Yeah. So that is whenever you want the resource assessment, you have to first get the assessment, okay, because you are going to invest a lot of money there. So the resource assessment of wind also the same kind only, because you are going to invest crores of rupees. Then what you have to do? Your assessment should be very carefully. You have to do it. So that is here is the wind resource assessment. The output, the input of the wind turbine is completely the wind turbine. The output of the electricity generation is completely depends on the resource only. If the resource variation is there, output also it will vary, right? So that is there. So the wind resource assessment is the quantification, how much the wind is available at any particular location, and also the compute the parameters such as average wind speed, average wind energy density, and average annual energy production, and the proposed power plant. Okay. So what is the resource assessment? Why do you want to assess the resource accurately? See, whenever you want, I said example, suppose we want to, get water from the well, then you have to first assessment. In case if you are doing the wrong assessment, if you are not getting water, what you'll do? See, you have done the wrong assessment. What you have done it, you have drilled for 1,000 feet. Then after that, there is no water. You have spent 80,000 to 1 lakh rupees, simply the waste of money. Then resource here also. See, if you are doing that is any wrong assessment, then what will happen? Your entire money will go off. So that is the first step. The wind energy project. The first step is a resource assessment, right? The resource, when you are doing the resource assessment as accurate as possible, you can plan your wind farm accordingly. Just you can see how we have planned. It means that this location has a good wind power potential, and also you will get a good energy output. So that is a proper wind resource assessment is a cornerstone of every wind project, especially as the environment for wind projects become increasingly the merchant. Okay, so the how much energy which is available from the wind. So the equation which it gives information about how much power available in the wind. You know the, you are the mechanical engineers, you know the what is the power, what is energy. What is the power? It is the rate of doing work. What is energy? It is capacity of doing work. So now we want to calculate that is the power. And how power means, you know, that is a rate of doing work. Okay, that is the rate of doing work. Yeah. So rate of doing work, rate of doing, that is a time. It means that how much energy, it means that how much energy which is the flowing through a rotor. So this is the turbine, right? This is the rotor. How much energy which is flowing through the rotor. It means that, for example, just you can see you are sitting in the room, right? You are sitting in the room. You have the window. The how much wind is blowing in through this window. This is the area, right? So it means that, see, the wind. So wind is, it is a light substance. An object which is moving from one place to another place, the energy which hold is that called the kinetic energy, right? This kinetic energy, whatever it may be, the kinetic energy is the object which is moving. Even though the wind is blowing from one place to another place, which holds the kinetic energy, right? So this kinetic energy, the kinetic energy, you know the formula, the kinetic energy equal to half mv square. Here the m is nothing but it is the mass flow rate. What is the mass? I mean, how much is the mass which is flowing through this window or through this area of the rotor. So that is the mass flow rate. What is the mass flow rate? You know, the mass flow rate is depends on the density. What is the density of air which is flowing? What is the total area which the wind is blowing? What is the velocity, at what velocity wind is moving? So this is called, that is the mass flow rate. Now the power available in the wind is equal to half rho a v into v square. That is equal to half rho a v cube. It means that power available in the wind is half rho a v cube. So it exhibits a highly non-linear cubic, depends on the wind speed. So this is the wind speed which is available, the power available in the wind. So you know the density, what is the density of the air? That is 1.223 kilogram per meter cube. And rho is nothing but air density, v is nothing but the wind speed, and yeah, v is nothing but the wind speed, and for the a is nothing but it's a cross-sectional area. So you know area is equal to pi by 4 d squared. So that you know that, right? Next, yeah. So this is the wind characteristics. What do you want to know about the wind characteristics? Now I told you about power is equal to half rho a v cube. You see that power is directly proportional to the v cube. In case the wind speed is 2 meter per second, what will be the power? That is 8 watt. In case the wind speed is 5 meter per second, what is the power now? 125 watt. You see here, the change in the difference is only 3 meter per second, but the power changes is, that is almost, it's a 14 volts. Imagine it, how the wind speed is, you know, the how you have to assess the wind speed, how the wind speed is important. So since the power is directly proportional to the v cube, then you should assess the wind at the site specific locations. You should know the knowledge of what is the site specific wind speed. I told you also the wind speed vary from place to place. This is the place 1 and place 2, and vary from place to place, and time to time also it will vary. So that's why then you should assess, that is a site specific, where the wind is there, that is site specific wind speed pertinent to wind turbine include. Generally you measure the mean wind speed. What is the mean wind speed? So mean wind speed means that is the average wind speed. What is the average wind speed? Whenever, so you may know that, okay, this particular site, I have the 5 meter per second. What does it say that? Only the 5 meter per second. It means that nothing gives information about, only the headwind is, that is the 5 meter per second. And next, you should always know the wind speed distribution, how the wind is distributed in a year, how the wind is distributed frequently. This is called, that is a frequency distribution. This is the wind speed distributions, right? And yeah, so uh, here you can see the wind speed frequency. So this macro meteorological range, micro meteorological range. Macro meteorological range gives information about yearly how the wind speed is there. So each peak which gives what is the yearly peak of the wind speed. But the micro meteorological range which gives what is the peak of the every 10 minutes wind speed. So this I told you. So mostly we get the southwest monsoon. It's the May to September, and the wind speed during November to March also it will be, but it's a low. The best windy sites. You are in Andhra Pradesh. So Andhra Pradesh we have the high potential, and Kerala, Tamil Nadu, Karnataka, Tamil Nadu, Gujarat, and Maharashtra, and some is also Madhya Pradesh also we have it. Madhya Pradesh also we have the good wind speed. So what is this? So this is called, that is a tunnel effect. See, what is a tunnel effect? When the wind comes from this is, this, I mean, this multiple, this area. And when it comes between these two hills, it becomes skewed, right? So you might have seen in Tamil, it's called the Murukku. See, you are putting, the mass of floor, wet floor, and you are compressing. So after compressing and the fine hole, you will get the small aperture hole. You will get this lengthy of things that it will come at the pressure. So the same way, when the winds comes between the two hills also, it becomes skewed. Once it's skewed, its exit path has, that is a good wind speed. For example, the entry path. The entry path has a 5 meter per second. The exit path will have, that is a 8 meter per second. Then I told you. Now you see the power is directly proportional to the VQ. Now 5 meter per second means that power is equal to 5 into 5 into 5. That is equal to 125 watt. Sorry, 5 into 5, yeah, 125 watt. And exit path, if you have the 10 meter per second, power is equal to 10 into 10 into 10. That is equal to 1000 watt. See, the change in the wind speed is only the 5. And here 125 to 1000 watt, it's increasing. Right. So Tamil Nadu, we have the very good passes, like, this kind of passes. And we are getting for Alvaimuli Pass, Ingota Pass, and Palakkad Pass. So we are getting the benefited. So this is the wind potential map. You can see the wind potential in Andhra Pradesh. Andhra Pradesh, we have very good potentials, right? So this is Andhra Pradesh, we have the very good potential. So this is the wind potential map. What it says it gives the indicative information about how much the potential which is available in our country. So we have assessed. This is at the 50-meter level. This is 80-meter level. This is the 100-meter level. And this is the 120-meter level. This is 20-meter level. Right. You can see the map. This is at 50-meter level. We have assessed as a 49 gigawatts. Sorry. One moment here. So it has come back. I don't know why it has come back. I'll try to do. Okay. Yeah. Yes, sir. So at the 50-meter height and 100-meter height and yeah, 109. At 50-meter height, it is a 49 gigawatt. At 100-meter height, it's 103 gigawatt. And at at 100-meter height, 302 gigawatt. And this 120-meter height is 695 gigawatt. So see the potential and how much is the potential which is there in our country. One moment. I don't know why it's not going there. Sir, one moment, sir. I'll share it again. Yeah. not moving. Yes. Yes, sir. Yeah. So this is the way, right? 120 meter, 100 meter level. So what it gives information about, that is the indicative potential. Indicative potential in terms of watt per square meter. It means that per square meter, this is the rotor area. So this is the rotor area, right? This is the rotor area per square meter. What is the potential? It may be the 200 watt per square meter square, or it may be the 500 watt per square meter. It means that each color codes, right? So each color code which indicates what is the potential. For example, this is the 100-meter map. So this is the Andhra Pradesh region. This Andhra Pradesh region, just look at here, almost green and orange is there. I mean, yellow and oranges are there. It means that this particular location has wind speed is in the range of 6 to 6.5 meter per second, and wind power density is 250 to 300 watt per square meter. So this capacity utilization factor is 22 to 25. For example, in the state of Tamil Nadu, this particular region, we can see the wind speed is in the range of 6.7 to 7, and wind power density 350 to 400 watt per square meter. Right? These are the excellent locations for developing the wind farm. Right? How we are measuring the wind speed? So measuring the wind speed is that it means that we have to install the tall towers. You can see the onshore. It means that onshore is where you can install on the land. You can see where I am standing on the mast. So yeah, so this is the 100-meter meteorological mast. This is on land, and this is the offshore. When you are installing your met mast in the sea, that's called the offshore. This is called the onshore. So for at the 100-meter height, we mount many instruments. So this is called that is anemometer. We mount like this, and other instrument also we mount it. So what are the different instruments are being used? There's the cup anemometer, van anemometer, ultrasonic anemometer, hot wire, and high-tech devices. We use it. So these are the instruments. Now we have seen the met mast. These are the meteorological mast. At multiple height, we install it. At multiple height, right? So yeah, so this is the anemometer. When the wind comes and contacts the surface of the cup, this is called the cup anemometer. The cup will start rotating. The number of rotations is directly proportional to the wind speed. Right here, you can see this is the wind van. Wind van. Okay, when the wind is coming from this direction, the shaft will go towards this direction, and this is the van will go lee side of the direction of the wind. In case, suppose the wind is coming from this direction, now the shaft, right? So this shaft will move towards this direction, and the van will go, I mean, this direction. So now the wind speed is coming from this direction, right? So apart from this also, we have to measure pressure, I mean the temperature, pressure, and the humidity. So why we have to do it? Because I told you power is equal to half rho A V cube. The rho we cannot measure it, but we can derive it. You know the basic formula of power is equal to, I mean rho is equal to P by RT. How we have derived this one? You know the gas constant law, PV is equal to MRT. I hope you have studied. Sorry. So PV is equal to MRT. From this, you can derive rho is equal to P by RT. So P is, that is atmospheric pressure. R is the gas constant. What is the gas constant? 287 joule per kg degree Kelvin. And T is the temperature. Right. So this is the way then we are doing the measurement. And apart from this also, we use, that is a sonic anemometer. What is the speed of the sound? What is the speed of the sound? 340 meter per second. So this 340 meter per second, we can this sound will travel. Correct. So the sound travels. So the sound travels 340 meter per second. And here you can see this anemometer, cup anemometer. This is the cup which is coupled with the shaft. And here we have the bearings. because it has to rotate. Here is the bearings. It has to rotate. So after some years, what will happen? The bearing will become, the bearing will have, that is a wear and tear. So after some times, the measurement will not give the proper result. But to avoid such a thing, we can use the sonic anemometer. The sonic anemometer is the antennas. The air will travel from one end to other end, right, at the speed of 340 meter per second. In case the wind is flowing from this direction, what will happen? It will measure the wind direction and as well as the what is the wind speed. How it will measure? Because since the wind is flowing from this direction, depends on the strength of the wind, the flying path will change. It means that travel between these two antennas and return back to the same antennas. Okay, return back to the same antenna. How much time it will take? Then what is the then this from this one we will calculate what is the wind speed and which direction wind is blowing. So other high-tech devices also we can use it. This is called, that is the SODAR. This is called, that is the sound detection ranging, sound detection and ranging instrument. Sound detection and ranging instrument. So this is the high-tech devices we use it. So previously, when you want to do the measurement, you have to install a meteorological mast at the height of 100 meter, 120 meter, 150 meter. Here, there is no need to install the meteorological mast. Simply, you can place a device. So this also working basic principle of the Doppler shift. I hope you have studied about the Doppler shift. What is the Doppler shift? So Doppler shift you might have studied. What is that? See, when you are standing on the platform of the railway platform, when the train is coming from towards this direction, you are standing on the platform, right? You are standing on the platform. The distance is 3 kilometers. When the driver makes the horn, okay, then how do you hear the sound? You will hear very less sound. It means that the frequency, because of the frequency is less frequency. When it approaches you, then sound will be very high sound. It means that high frequency, high frequency. So when it's receding you, what will happen? Slowly the sound will decrease. Right, this change in the frequency, this is here one frequency will be there and here other frequency will be there. Here one frequency will be there, here frequency will change. This change in the frequency is called the Doppler shift. So here also this sonic anemometer, this sonic anemometer and this high-tech devices are working basic principle of the Doppler shift. I told you the speed of the sound is 340 meter per second or 42 meter per second. So depends on the temperature, this will vary, right? So what it contains? This solar which contains many antennas. You can see. So here I have, that is a 8 into 8. That means 64 transducers are there. This transducer can emit the sound to the atmosphere. It will go vertically, right? So here you can see the wind is blowing from this direction to this direction, and the atmosphere which has the inhomogeneous temperature particles. You can see the small particle, large particle, small particle, large particle. When the sound which goes upper direction, it will hit on the surface of the particle, then it will echo back. Okay, depends on the height. I can do the measurement of up to 2 kilometers or 5 kilometers also. I can do the measurement by using this solar up to vertical height. Correct? Right. We can. So by using this one, because I am sending some frequencies and return after hitting the surface of the particle and it's returned back. Okay, I am sending some frequency, return will get the some frequency. For example, 1550 nanohertz or hertz I am sending it. But return frequencies maybe 1650 or something, 1250. It depends on the wind speed, the hertz will change. So based on this, I can measure the wind speed. I can do the measurement of east, west, north, east and west. This is called the zonal. This is called the meridional, zonal, meridional, and vertical wind speed. So that is the U, comma V, comma W. U is that the east-west zonal, and this north south is the V, and the vertical is W. It means that when you want to calculate the wind speed of the horizontal wind speed, you will get that is U squared plus V squared plus W squared. Root of this one is that is the wind speed. In case we want to know the direction, we can do theta is equal to tan inverse of U by V. You can calculate it. So from this, I can find out the which direction the wind is blowing. So this is called other instrument, how we are using measuring the LiDAR. So LiDAR is light detection ranging instrument. Light detection and ranging instrument. That's called that is a LiDAR. So instead of light, instead of sound, we can use the light. What is the speed of the light? Speed of the light equal to 3.81 into 10 to the power yeah, 3.1 into 3.1 into 10 to the power 8 meter per second. This is the speed of the light. So we always used to say the example. So thunder and lightning happened at the same time only. Which one reaches there? The first lightning, because the speed of the light is 3.1 into 10 to the power 8 meter per second. The sound will travel only 340 meter per second. See, that's why the difference, because of the speed, the light travels first and the sound travels second. Right. So how it is working? So it's working, so this is also working basic principle Doppler shift only. I'm sending some laser pulses to the atmosphere at different frequencies. Right. So atmosphere which has the particles. Hello. Yeah. Hello. Some disturbance is there, sir. Yeah. So the atmosphere
Okay,
which,
sir. Stop.
yeah. So the atmosphere which has the the aerosol particles. See, this aerosol particles, since it has it, when you send the pulses to the laser pulses to the atmosphere, the it will hit on the surface of the particles. Once it hits, then it will go back. Right. I send that is a 650 nanohertz. I'll get that is a different frequency, the receiving frequency. So the change in the frequency is called the Doppler shift, and I can find out because of this the change the wind speed, the frequency also will vary. Receiving frequency also will vary. So from this, what is the sending frequency? What is the receiving frequency? At what time? What is the time interval? I got this information. So based on this, I can calculate what is the wind speed which is available. Right. So the wind resource assessment in Nive. So wind power potential, the main purpose of the resource assessment in Nive is that assessment of the wind power potential across the country by installing the meteorological mast for getting the ground based instruments. Right. You can see here, these are all the dots are where we have installed our meteorological mast. This is the Google map. So from Kanyakumari to Kashmir, Arunachal Pradesh to Gujarat. Right. So all over the country, we have installed almost 990 meteorological stations. Okay, met station we have already installed. And also the private, they have installed more than 2,000 meteorological masts across the country. Right. And we have provided technical support service for more than 9,000 megawatt. And so I do not know how many of them you know, Professor Annamani. So she was a pioneer who changed the way we gauge weather. Currently, whatever we are measuring the weather, she was the pioneer at the time of this one. She was a great woman scientist in India, and many of them they may not know that she was given the entire time for dedicating to measurement of wind and solar, and as well as developing the instrument. Actually, she born in 1918, August 23rd, 23rd, right. She completed the 100th years, right. Centenary, we also celebrated the centenary birthday of Professor Annamani. She came from Kerala, Trivandrum, and she joined in the Indian Meteorological meteorological department in Pune. She was given assignment to develop instrument for measuring instruments. She developed whatever the material which was available. The instrument she developed, right? She developed and started the network of measuring in India in 1958, right? Started, and she has made a lot of things and measurement she made it and collected the data, and still you can see her books, many books are available. Just 1 minute. Yeah. I mean, she has written many books, and now it is a Bible of, the solar resource assessment and wind resource assessment. She was also a weatherwoman of India, right? So whatever the development is happening now, both wind and solar, the part of the credit goes to Professor Annamani. We should always respect her for her dedication of work to the nations. Yes, so after 1 year, we have to collect the data. So after collecting, then we can create the frequency distribution. The frequency distribution, how frequently the wind speed is available in any particular direction. In a year, you have the 8,760 hours. So whatever the data you have done the measurement, every 10 minutes we do the measurement, 10 minutes, for example, 0010, 0020, 0030. Right. These are the measurement I have it. So like this, I'll make it into convert it into 1 hour. So 1 hour means 8,760 hours. 8,760 hours. Separate the wind speed, for example, 3 to 5 meter per second, and 5 to 6 meter per second, 6 to 7 meter per second, 7 to 8 meter per second. Put it in separate bin. Right. Number of hours. How many number of hours? 500 hours, 1,000 hours, 2,000 hours, 2,500 hours. So like this, how many number of hours this particular wind speed was existing. Now you can make a graph. So this is called, that is a wind rose, at which direction the wind is blowing. So this is so that southwest and northeast. So the predominant wind direction is southwest, and the other direction is there is a northeast. So that is the information which it gives, and also what is the percentage of frequency, percentage of time the wind blows in particular location. For example, this circle shows that 10% of the wind speed, and 10% is the time of this much wind speed is there, and 20% of the time this much wind speed is there, right? So this is the color code. And so whatever the data you have collected, your project feasibility is completely depends on your wind speed measurement as well as the deriving quantity. So we have all measured the wind speed, the direction, which direction wind is blowing, and what is the air temperature, what is the air pressure. From this we have derived the wind turbulence. What is the turbulence? Turbulence is nothing but it is it is a stochastic in nature, at the variation of the wind speed and the direction in a second, right? So that is called the turbulence. Wind shear, I told you, the wind speed will increase to the height, and air density, rho is equal to 1.223 kilogram per meter cube, and energy density, how much energy which is available in any particular locations, right? From this only we are this one for carrying out the site wind farm modeling, financial modeling, network, bankable wind data, and finally the project feasibilities. So this is the definition of wind classes for wind measured 50-meter height. So marginal wind is 5.6 to 64 meter per second, and fair wind is 6.4 to 7 meter per second. Good wind is 7 to 7.5 meter. Excellent wind is 7.5 to 8. The outstanding wind is 8 to 8.8 meter per second. So mostly in our country, you have now just to go back your map. There you can see. So mostly in our country, we have this wind speed 5.6 to 6. This is mostly available. But this is the less region we have this one, and most very less region only we have this kind of wind speed. Then after collecting the data, you can do the microsighting. It means that microsighting is nothing but yeah. So that's what I will say. The microsighting is nothing but how you have placed your wind turbine. Yeah. This is called that is the micrositing. Micrositing means how you are placing the wind turbines. Okay, so if you have that is the land, you have to optimize the utilization of the land, optimize the utilization of your load, and that is the land optimum extraction of energy from the wind. So that is called that is the benefit of siting. I have placed here, I have placed here, I have placed here. The same one turbine to next turbine, I will give the space of 5 times of the diameter, and the back side is one turbine to next turbine. I'll keep the 7 times of the diameter, the spacing. Otherwise, what will happen? The first turbine will create the wake, conical wake. It means that this is the conical wake. So it will create the conical wake. So when this conical wake will end means after 20 times of the diameter. The optimum distance is if we have that is 7 times of the diameter, I can place it properly. Yeah. So this previous one, that's the trend. So earlier we discussed the LiDAR. See, now we can also place, in order to increase the efficiency of the turbine, we can place the LiDAR on the top of the turbines, right? So what it says that it will send the beam towards it will send the beams towards the direction of the wind. So when the wind is coming from this direction, it can sense up to 80-meter distance. From the 80-meter itself, it will give the information to this turbine. The turbine accordingly is oriented towards the exact wind direction, so that the wind speed can be, so that the efficiency of the turbine can be improved. So wind measurements. So wind measurements, we can do the measurement by using LiDAR at horizontal as well as the vertical. So horizontal as well as the vertical direction, we can do the measurements by using the LiDAR. So the LiDAR can scan, this is called the scanning LiDAR. Up to 180 degree it can scan. You can see the scan, 180 degree, up to 15 kilometer, horizontal position, and vertical position up to 5 kilometer, we can do it. So such a kind of instruments are there. And also when you want to develop your wind farm, so we have to do the analysis. So linear tools we can use like the WASP Wind Atlas Analysis and Application Program, and this is the CFD tool. So CFD tool, we can see the how the wind is blowing over the surface of the land. See here, this is called the lower surface, this is the upper surface, where the turbulence is there, where you want to place your wind turbine. So such a kind of analysis we can do, that is the CFD modeling. And many other non-linear tools are there, and prediction and forecasting, right? So now the one wind turbine is called, that is called the single wind turbine is called the wind turbine. If you have the multiple number of turbines, this is called that is the wind farm. This is called the wind farm. Number of wind turbines are grouped together. Right, this is called the wind farm. What is the advantages? Single wind turbine means no, you have to make the specialized person there. It will become the costly, and also wind is a multiple wind turbine means easy to connect to the grid, and also the single skilled personnel can be placed so that he can take care of the entire thing. Right, and also the SCADA system, we have supervised control and the data acquisition system. Supervised control, that's called the SCADA system. The SCADA system will monitor and control the entire wind farm and the turbine. Monitoring means each turbine's location, we have the instrument. This instrument will measure the parameters, various parameters like what is the stress, what is the strain, what is the wind speed, what is the, all this instrument will collect and give the information, and this is being monitored. This is being monitored by the supervised control system and controlling the machine of a plant. That is, the entire thing is being controlled. Right. So what are the essential requirements for development of wind farm? First thing is that is you need the logistics. It means the road. Okay, the proper approach road, it has to be there. That's called the logistics, right? And proper wind resource, the wind resource, logistics, and the transmission line, where because after after generation of the power from the wind turbine, we have to evacuate to the grid, right? So the grid should be nearby the wind farm, and reliable power purchaser. Who is going to purchase my power? Whether the electricity board is going to purchase or third party is going to purchase it, and techno-economic and O&M needs. Okay, now you can see the turbine. So the wind turbine, which has more than 8,000 components, more than 8,000 components are there in the wind turbine. But these are the major components, like rotor. Rotor is nothing but just the blades. 1, 2, 3. So three blades, right? So that there are three blades, and this is called the hub. This hub and blades are called, that is a rotor, called the rotor. Yeah, this is the tower. Okay, tower, just like that, it operates the entire structures. And the drivetrain. So drivetrain means driving. Okay, it's driving the torque from one place to other place, right? So yeah, just a minute. Sorry. Yes, sir. So these are the major components what I am explaining here, right? So the control system, which has the control system, one on the top of the tower, other is the bottom of the tower. Here will be there, yaw system and mainframe and nacelle, right? So this is called, that is a nacelle. Okay, this nacelle which protects the drivetrain components. The inside the nacelle we have this drivetrain components. Okay, this drivetrain components, you can see what the different drivetrain components are there. This is called the hub. So hub has the space, okay, to provide to insert the turbine blades. This is the blade with the hub. Okay, it connects. Okay, the hub which connects the blades, the hub which connects the blades and the shaft. You can see blades and the shaft which connects the blade. The drivetrain here. So the drivetrain components are there, like the gearbox and the generators, right? So the blade. Some of the turbines, the turbine which has the bearings between the blade and the hub. Here you can see the bearings. Okay, I will tell you the examples. You can see, yeah. So you can see the shaft also here. The hub is the shaft. Yeah. So what is the purpose of the drivetrain? So drivetrain, it transfer the, the drivetrain which transfer the force in terms of the torque from rotor to the generator via the mechanical elements. Okay, this is called, that's a drivetrain. What are the mechanical elements are there? Here you have the shaft, the rotor, which is coupled with the shaft coupled with connected to the gearbox. The gearbox is connected to the shaft to the generator. Okay, so now we can see here what is the purpose of shaft. This is called, that is a low speed shaft, because the rotor which rotates at the low rpm, like called 10 rpm or 20 rpm, right? So the torque is here, so since the rotor which is rotating, the same rotation, since the shaft is attached with the rotor, the shaft also rotate at the same speed. That's why it's called the low speed shaft. But I need, here it's rotating at 10 rpm, but my generator needs 1000 rpm, right? So in between, like a two-wheeler and a four-wheeler, I have to a two-wheeler, four-wheeler, we are giving the step up the speed and step down the speed, but here only the step up the speed, because here I have the 10 rpm, here I needed the 1000 rpm. Now the gearbox is there, so the gearbox will step up the speed from 10 to 1000 rpm. How? The ratio of gear 10 by 1000 equal to 1 by 100. So 1 is to 100 time. If this rotor is rotated to 1 rpm, and the gearbox has to rotate at 100 rpm, that is a 1 is to 100 ratio. That is a ratio it has been placed. 1 means that 100 times it has to rotate. It's one rotation, 100 times rotation of the output. So then only it can get that is a 1000 RPM, right? So mostly in mechanical engineers, you should know that mostly we use the two different types of gearbox. That is a parallel shaft gearbox. You might have heard parallel shaft gearbox, and the other one is that is a planetary type gearbox. Planetary type gear. Parallel shaft gear means when you have the wind turbine, it's a lower capacity, less than 500 kilowatt, we can use parallel shaft gearbox. And in case if it is a megawatt class of turbine, we always use the planetary, okay, planetary gearbox. Planetary gearbox. You know the advantages, disadvantages of all its mechanical industry. You know that advantage of planetary gearbox. It is completely. It is a very compact. Okay, it is we can transmit the large transmission in the smaller space and smaller size. For example, in case if you want to go for the megawatt class of that is a parallel shaft gearbox, it will become there is a too. I mean the too bulky one, and the weight there is too much weight will be there. In order to avoid such a thing, we can reduce the size by 1/3 if we are using the planetary gearbox compared to parallel shaft gearbox, right? So that is the more advantages in this planetary gearbox. And the control system, you can see the control system. The control system is that is the heart of the system, how it is controlling. Okay, the control system which has many computers and the power electronics. Just look at here, the computers are there. You can see even the simple system, how it will be there. It means that I mean the thousands of computers are there here. So thousands of the computers, the power electronics which controls the entire turbines. Okay, now we can see the basic principles operation of the wind turbine. I told you the different components of the wind turbine, right? When the wind is blowing from this direction, it will hit on the blades of the turbine. But the blades of the turbine, you might have studied the aerodynamics, right? What is the aerodynamics? The shape of the blade is aerodynamics. What is the aero? Aero means air. Dynamic means that is the, I mean, the interaction of, the dynamic means there is a movement. Aerodynamic means the interaction of wind with the solid object. That's called that is the aerodynamics. How it is working when you are placing there is when you are placing the blades, I mean the rotor in the pool of the wind, the blade will start rotating, right? So the rotor will start rotating. Once it's started, I told you it is connected to the shaft which is turning, and the gearbox will start, step up the speed, and there the outside all the high speed shaft to generate the electricity. Okay, so how this creating? Since the surface is okay, you might have seen the surface of, I mean, the cut section of the blade. So this is the blade. Now we can see this is the entire blade sections. If you are cut into two pieces, you can see the shape. This is the cut section of the blade. You can see the surface. So this is the aerodynamic. So aerodynamic surface. Now we can see you have the two-wheelers, four-wheelers, how it has been designed. Why the aeroplane is designed in such a way? Because the air has to, I mean, travel up and travel down. Now, when the wind is blowing from this direction, it will hit on the surface of the blade. That is a leading edge. You might have studied this is called the leading edge, this is called the trailing edge, and trailing edge. So when the wind hits on the surface of the blade, the wind is divided into two portions. Upper portion is there is the high speed and low pressure, and the lower region is low pressure and the low speed. Sorry, low speed and high pressure. Right. So now what will happen? You might have studied. See, the object will move from high pressure region to always to the low pressure region. Correct. So here is the high pressure. The bottom has that is the high pressure region, and upper has that is the low pressure region. The high pressure region try to move to the low pressure region, then automatically the lifting is happening there. So once you see the entire area, it's being like this only. Okay, so entire area. So what will happen now? It start rotating the entire blade. Now it's a churning and generating the power. So this is the mechanical power. That is a torque into speed divided by the constant. Here, a fraction of the wind intercepted by the blades. See, the wind is blowing here. The fraction of the wind is intercepted by the blade of the turbine, which is converted into rotary motion. You see the fraction of the wind is accepted by the blade, and blade of the turbine is converted into rotary motion, rotational mechanical power to drive the electric generator. Here the mechanical power is, that is the torque. Right. The maximum conversible efficiency is only 59.23%, 23% only you can extract from the wind. Whatever the wind turbine blade doesn't matter, because that is a part of the wind has to move through the blades. Then only it can generate. It can generate the lift and produce the power. Otherwise, it will act as a disk. Right. So this picture which I explained about, this is the predominant wind direction I have, that is a rho A V cube. Before entering this one, it will become converted into 2/3 of the power. I mean, after hitting the wind turbine, it will become, that is a 2/3 of the wind. Then 1/3 of the wind is passing backside of the turbine blades. Right. So this is the fraction, that is the rotor efficiency coefficient of performance is the fraction of wind power extracted by the blade divided by the power available in the wind. How much is the fraction of power extracted by the blades, and what is the power available in the wind? Actual divided by, that is a theoretical. Actual divided by the theoretical. Right? That is called the then wind turbine technology. Now you can see that what are the different technologies are there. So different technologies are aerodynamic principles. Based on the aerodynamic principle, we can divide, and axis of orientation, and the power control concepts, and for yaw orientation, rotor position, type of hubs, number of blades, rotor speed. So based on this one, we can divide. Okay, this is aerodynamic principles. I have already explained to you how this aerodynamic principle is working. Right. So based on this one, this aerodynamic turbine is called the drag force. What is the different forces acting on the blade? So this is the blade when the wind hits on the surface, and it's creating two forces, four forces. This is called the lift force perpendicular the direction of the wind, and this is the drag force parallel to the wind. Parallel to the wind is called the drag force and the lift force. Right. So the other forces acting, there is a gravity force, and other forces acting, this is called the thrust force. These are the four forces acting on this turbine. So this is the drag force, that is a parallel to the wind. So this is the drag force. See, when this is the drag force turbine, there is 7-inch turbine. The drag force turbine, the drag force will be more. FD, there is drag force will be more, and the lift force will be less. Right. Drag means there is a drag force. See, for example, when you are traveling by car or train, you extend your hand outside, then you will come to know that, see, the different forces. When you are keeping your hand in flat, okay, this is the wind. Okay, when you are keeping the hand in flat, what will happen now? The entire your hand will be dragged by the wind. Okay, so there will be no lifting. In case if you are keeping a particular direction, what will happen when it hit on the surface? Try to lift, correct? So try to lift. So now it will happen lift force and drag force. If you have the drag is more, this is called the drag is more. That's called the drag type wind turbine, but the efficiency is very less. 15% only will get, less than 15% only will get it. Yeah. So the next one is the lift type turbine. So lift type turbine means I have told you. Now the FL is more and FD is less drag force, right? So that's called the lift force turbines. And axis of orientation, whether it is a horizontal axis, because the axis of orientation is parallel to the ground. So So that's why it's called that is a horizontal axis wind turbine. The advantages are, I told you, the wind, since the wind speed is increases the height, you can also raise your turbine according to the height so that you can extract maximum energy from the wind. Other advantages, that is, yeah, so that is there. And the disadvantages in this one is, see, you have to keep all your drivetrain components on the top of the tower. In case if there is any issues, problem, then you have to bring it down to the ground. That is a disadvantages in this one. And also, when the wind is blowing from this direction, this always rotate in this direction. Since the wind is in variable nature and change the direction, when the wind is coming from this direction, the entire rotor has to move towards this direction. This is the rotor, move towards this direction. So this is the direction of the wind. So now what is the disadvantage? It has to rotate towards the direction. This is called, that is a yawing. Okay, so this is called that the yawing. That is a disadvantages. But you can see the vertical axis wind turbine at any direction, that is omnidirectional. If the wind is coming from any direction, it can start rotating. So this is called this is called the vertical axis wind turbine. That is the advantages. And also all the drivetrain components can be placed on the ground. Okay, drivetrain components can be placed on the ground. If there is any problem here, no need to wait for a long time. At least 1 or 2 days, it can be repaired and replaced. That is the advantages, right? And the disadvantages, that you cannot increase the capacity. The world, the largest machine is 4 megawatt, but this one is the largest machine is 12 megawatt. Currently, that is a 13 megawatt is under process, and in future they may go for single turbine is 20 megawatt. Yes, onshore wind turbine and offshore wind turbine. When you are placing turbine on the land, is called the onshore. When you are placing the turbine on the sea, is called, that is offshore turbine. The advantage of offshore turbine is the surface is smooth surface. Right, there will not be much turbulence will be there. But here, the some of the location may be the flat. Other location it's maybe undulated surface. When the wind is blowing on the surface of this one, it will create the disturbances on the wind. So the wind speed will be reduced. Either you can use a one-bladed turbine, two-bladed turbine, three-bladed turbine. So one-bladed turbine is you can save the two blades. Correct. Mostly we use a three-bladed. Only one blade. Two-blade cost I can reduce it. But the thing is that I have to make the counterweight. And the efficiency is less. Efficiency is less than 15% only. Less compared to, there is a three-bladed turbine, a two-bladed turbine, almost 10% less. But the thing is that to achieve this efficiency, it has to rotate faster. When it rotates faster, it makes the sound, wishing sound will be there. And two-bladed turbines. Advantage is that is you can reduce the one blade. But other thing is that here, see, in order to reduce the one blade, we have to add the additional mechanism called the teetering. The blades back and forth. This mechanism should be there so that we can reduce the load. And mostly we use the three-bladed turbine. It is three-bladed turbine is balanced equally. So three-bladed turbine, one blade is up, one blade is other direction, other blade in this direction. It means that each has the 120 degree each other. Okay, so that is the 120 degree. You can yeah, so this is the 120 degree each other we can use it. Next is the control system. I told you. So the control system which has the master, the two controller system, one is on the top of the tower, other one is the bottom of the tower. The control system purpose is to control the operation by active or passive, means to keep operating parameters within the normal limits. That is the purpose of the control system. And the safety systems are activated when a result of control system failure. When the control system failures, automatically the safety system has to come into the place so that we can avoid any damage of the turbines. So wind turbine control objectives: optimize the power production and the power limitation. The purpose is the maximum power point tracking, power limitation, and mechanical load reduction, and the compliance with the grid connection requirements and disturbance mitigation. These are the purpose of the control objectives. So power control. So power automation. Why do you want to control the power? Because at a low wind speed, I have to maximize the power. At high wind speed, I have to limit the power. So that is the concept of power control. So power control concept, power optimization for the low wind speed. When I have the low wind speed, I have to try to extract maximum energy from the wind. When I have that is a high wind speed, I have to limit my power. It should not exceed. If it exceeds certain limit, what will happen? My turbine get damaged. In order to avoid such a things, we have to limit the power. So there are three approaches are there. That is stall control, pitch control, and active stall control. This is the stall control machine. The stall control machine, you can see here, this is the hub, this is the blade, right? Blade. So the blade is firmly fixed on the hub. There is no bearings between hub and blade. There is no bearings, right? So, this is the way. This is the way it has been connected. So what is the advantages here is here the aerodynamic control is there. You can see the blade surface. The blade surface firmly fixed. When the wind is blowing on the surface, that is the streamlined, simply flow on the surface of the blade. Okay. When the wind speed is more, this angle when the wind speed is high, what will happen? This will create the turbulence. When the wind is pass on the surface, it will create the turbulence. Right. The purpose of the creating the turbulence design is that to limit the power. To limit the power. That is the purpose. You can see here stall regulation at 8 meter per second. The wind is blowing on the surface of the blade. At 24 feet meter per second, it's creating the turbulence. Correct? It's creating the turbulence. The blade is in a stall controlled. Rotor are fixed firmly to the hub, implying simplicity and a low cost, but the turbine must sustain large thrust forces at high wind speed. At high wind speed, it has to withstand that is a high forces. Right. This is the stall control turbine. Yeah. So you can see the stall control turbine. The stall control turbine, you can see the power curve. Power curve is nothing but x-axis is the wind speed. The y-axis there is the power. The wind speed versus the power. So when the wind speed is increases, you can see when the wind speed 3 meter per second, 5 meter per second, it's 8 meter per second, 10 meter per second. This is the power 50 kilowatt, 100 kilowatt. Okay, this is a 500 kilowatt. This is a 1000 kilowatt. So 1000 kilowatt. When the wind speed increases, the power also increases linearly. When it reaches to the rated wind speed, the rated wind speed is the speed at which it can generate. That is the maximum power of the turbines, maximum capacity of the nameplate capacity of the turbine. Now, for example, it reaches at 13 meter per second, at 12 meter per second, it can generate 1000 kilowatt. When the wind speed increases, the power is coming down because it's doing that is a stalling. This is called that is a stalling region. Why it has to stall? I have to limit my power because of the stalling region. When it reaches a stalling region, so here when the wind speed is increases, create the turbulence. Once the creator start creating turbulence, the power will come down. Automatically, I limit my power and controlling my the entire turbine structures. Otherwise, what will happen? It will become the damage of the entire blade and the structure of the turbines. Right. Next, that is the pitch control machine. Now you see the pitch control machine. Here, the pitch control machine, the entire rotor is turned its own axis. It's turned its own axis. So now what will happen? Now you can see. Then first slide I shown. This is the hub. Yeah, the hub is. The hub. Okay, the blade is fixed on the hub through the bearing. So in between we have the bearings. So that what it can do, the blade can rotate its own axis. So one axis, okay, at 0 to 180, minus 5 degree to 180 degree, it can turn its own axis, right? So in such a kind of location, just look at it here. when the wind speed is increases, when the wind speed is reaches at when the wind speed is reaches at the rated wind speed, and it can generate the rated power. Even the wind speed increases, the power also constant, because the blade adjusts its angle of attack. Right? You know the angle of attack. What is the angle of attack? The mechanical engineers, you know that angle of attack. You know, this is the leading edge, leading edge. This is the trailing edge. Right? When you are connecting this leading edge to trailing edge, this is called, that is a chord. Okay, so this is called that is a chord line. Yeah. Okay, so this is called the chord line. Yes, leading edge and trailing edge. This is the chord line. So this is, that is the aerodynamic surface of the blades. Right. Yeah. So this is, you know, angle of attack. The angle of attack is the leading edge. This is the wind speed. The direction of the wind and the chord line. This is called, that is the angle of attack alpha. So the angle of attack varies, and incoming wind also, the wind observation also more, so that it can generate the constant power accordingly. You see here now what is happening there. At low wind speed, try to extract maximum energy wind speed. At high wind speed, it's, you know, it's maintaining the constant and limiting the power. That is the advantage. So this is the angle of attack. Yeah. And now you can see at 8 meter per second, the wind is blowing on the surface of the blade. That streamlined flow is there. Even 24 meter per second also the streamline is there, because of this the pitching of the blades. Yes, next is, that is active stall. Combination of, now you have seen there, this is the active stall turbine, right? So this is the pitch control turbine, right? Why it's the active stall, active stall turbine. It is taking the gain of the advantage of two active stall. I mean, this is a stall control turbine. So this is the pitch control turbine. Pitch control turbine is taking the advantage of both. So now what will happen when it reaches to the, when it's you know, this active stall turbine when it reaches to the rated power. See that pitch control turbine, I told you, when it reaches, that is a rated wind speed, rated wind speed is generating the rated power. Even the wind speed increases, it's always maintaining the constant power. So that is a pitch control turbine. And a stall control turbine, when it reaches to the rated wind speed, and the power, when the wind speed is increases, the power is coming down. But the active stall turbine, what is happening there? So even it reaches at the limit of, that is even the 24 meter per second, it's doing the negative pitching. So this is the call, that is a negative pitching. Now what is happening there? Now what is happening there? It's always maintaining, that is a constant power, because the pitch control machine, when it reaches the 25 meter per second, the turbine is coming down, I mean shutting down. But in this turbine, it's when it's doing, that is a negative pitching, that is a stalling, it is always maintaining the constant power. So that is the advantage of this stalling machines, active stall turbine. So controllable aerodynamic surfaces, that many surfaces, there are brakes there, and the yaw control. I told you, when the wind is blowing from this direction, what is happening? When the wind is blowing from this direction, the rotor has to move towards this direction. When the wind is coming from this direction, the rotor has to go towards this direction. So this movement is called, that is a yawing. So this is the yawing mechanism, right? You can see the how yawing mechanism is there, and this is the tower top. This is the motor. This is the, you know, this is the gears, and this is the tower. It will be, the tower is like this. So depends on the wind speed, just it turn. Okay, it turns the entire rotor towards the direction of the wind, right? So now we can see that how the wind turbine converts. So the wind turbine, I told you, it extracts energy from the a wind turbine converts the kinetic energy of the wind into electrical energy. I told you the requirement is you need always the low cost electricity, high availability, and survival. So this is, you know, energy conversion which is taking place into three stages. One is, that is aerodynamic energy. and mechanical energy, and next is that is the electrical energy, right? So there's a 3 stages of energy conversion is taking place. The first stage is that is the aerodynamic energy. So the aerodynamic energy conversion is, and wind is that is a linear motion, right? That is a linear motion. Here the linear motion is converted into rotary motion by the blades. So that mechanism, this conversion is depends on the aerodynamic efficiency, right? And the mechanical energy. So this rotor is, I mean, the rotary motion is converted into torque. So that's called, that is a mechanical energy. This it is happening in the gearbox and shaft. Then the mechanical energy is converted into electrical energy by the generator. So that is the basic principles of the energy conversion. You can see the wind power rotor and the gearbox. Here is the generator. Then and power converter will be there, and power transformer, it goes to the power transformer and transformer to supply grid. Now we can see the generators, right? So this is the generator. The generator we are using, there is a various types of generators, like the difference between the wind turbine generator and the wind turbine generator and thermal power generator is the difference is the wind turbine generator always connected to the grid. If there is no grid source, there is no power generation. Why? Because of the wind is, it's a variable in nature, variable nature. Okay, the wind is variable nature, and when the wind is variable nature, generates also the voltage and the power also, it's a variation. And when you are connecting to the grid, the variation will be there. So this then when you are connecting to the grid has to be, grid has to have, that is a stability. If there is no stability, the grid will get failures. Okay, then blackout day. The recently also might have read in newspaper the blackout day in Northern Grid, and also 5-6 years back also it was happening there in a blackout. Blackout means a completely shut down because of due to the instability of the grid. To avoid such things, so here the wind, I mean renewable energy power generation, it is always the mixing power. The base power is, so this is your total power requirement, and this is the 80% from the, for example, thermal power, 20% from the 20% from the from the renewable energy power. So the renewable energy power can vary, but the base power will be always the constant. Okay, so the generating voltage. So when the wind turbines are generating, when the wind turbine having the less than 500 kilowatt, so it can generate 415 volt. When the wind turbine generator is having, there is a megawatt class, then it generate the 690 volt. So the 690 volt, it is connected to the and converted into, transformed into 11,000, 33,000, 66 kV. Like this, it will go 110 kV, right? 110 kV, 220 kV, and 450, 750 kV. Like this, it will keep on, it will go. Yeah. So the different types of generators are being used. What are the different types of wind electric generators according to the principle of operation? Either we can use the asynchronous generator and a synchronous generator. What is the asynchronous generator? That is a squirrel cage induction generator. We can use the squirrel cage induction generator, wound rotor induction generator, and slip induction generator, and a dovefed induction generator. And also the synchronous generator, we can use the wound rotor and synchronous generator and the permanent magnet synchronous generators. So these are the generators that can be used. But the induction generator, mostly the induction generator is robust in construction. It is easily available, and the induction generator mostly is the squirrel cage induction generators, right? The induction generator, which has the stator and the rotor. So you might have studied in the basics of electrical engineering. This is called the stator, this is called the rotor. The stator always connected to the grid, right? So it will draw power from the grid. Why means? Because the stator has the coil. Okay, this has the coil. So when you when you give that energized, what will happen? It becomes the electromagnet. So it's working basic principle of the electromagnet. When you give the current, electric current, then it will become the magnet, right? That is the electromagnet. So when the electromagnet is created, it created, that is the electromagnetic force. Then it will induce the electromagnetic force in the rotor. The rotor field also will create one EMF. I mean this force. See, this rotor field and stator field move together, right? But the difference in speed is called the slip. You might have studied. So ns equal to 1, no, the slip percentage is equal to, slip percentage of slip equal to, maybe that is a 3 to 5%. Okay, so the slip, when rotor field and stator field together, both are same, that is synchronous. There is no power generation. When the stator power is more than there is a rotor power, sorry, when the stator power is more than the rotor power, this is called the motor. See, this is the stator power, this is the rotor power. When the stator power is more, rotor power is less, then it's called like the motor. When the stator power is less and rotor power is more, this is called the generator. So it will act as generator as mode. So since initially it's draw power from the grid, it will act as motor. When the wind power is more, then it will act as the generator. So that is the way then it's working. Right. Yes. Now you can see the synchronous generator. So synchronous generator, which is also the stator and the rotor, stator which is connected to the grid. I mean, connected to the grid, the same like induction generator, and the rotor which is connected to the external field. You can see the external field, that is a DC power. It's connected to the grid. Now what will happen? So this also get energized, and this also has the energized. This will generate that is the static. I mean, stators create the magnetic field, and the rotor also create the magnetic field. So stator field and rotor field together, it will join. This is called, that is a synchronous speed. Synchronous speed. Since it is having the synchronous speed, when the wind is more, because the rotor is connected to the rotor is this road generator rotor is connected to the the gearbox. Okay, the gearbox rotor and gearbox rotor is connected to the turbine blades. So when the turbine blades, when the wind speed is more, it gives a more torque and power is flown to the grid. Various types of wind turbines are there. Fixed speed wind turbine. So fixed speed wind turbine is nothing but okay. So fixed speed wind turbines. There are 4 types of wind turbines are there. It's called, that is the fixed speed wind turbine. The fixed speed wind turbine, you can see here, are constant speed wind turbine. But what does it mean, the fixed speed or constant speed? It doesn't mean that it all fixed speed, but the variation will be there only the 3 to 5%. Right. So that's a near constant speed turbine. Now you can see the rotor, it is connected to the gearbox and the squirrel cage induction generator. Here the stator is connected to the grid. So this is the grid via the soft starter for smooth running operation of the turbine. And you can see the capacitor bank to compensate the reactive power, because generally the wind turbines, it consumes the reactive power. So reactive power, see, both the generator and the generation and the consumption, it will create some, create some reactive powers. So the reactive powers in terms of it is the voltage, right? So the reactive power, the voltage is less in this so whenever the wind turbine is starting, what will happen, it will draw more power from the grid. If we are having, there is 1,000 numbers of turbines drawing more current, because 5 to 7 times of the current is need. Okay, it supply the current. 5 to 7 percentage of the 5 to 7 percentage of more current will take it. Okay, 7 times, not percentage, 7 times of the current. So now what will happen, when it draws 1,000 turbines, it means your grid, the grid source will get failure. In order to avoid such a things, the capacitor bank will supply this to the turbines, right? That is the purpose. So this is the fixed speed turbine. Is directly coupled to the grid. Very limited speed variation. The speed variation is only 3 to 5% only. Need a rather maintenance intensive. It is not, it's robust, and we do not want much control of this one. And it depends on the terminal voltage, active power generation, and the rotor speed. And you can see the fixed speed turbine. This is the synchronous speed, and the below synchronous speed, there is no generation, and above synchronous speed only it can generate the power. You can see the point 1 and 2. See, this is the torque, okay, operating range of torque, and this is the synchronous speed. So you can see the point 1 and 2. So 1 and 2, when the speed is increases, the torque also increases. It means the power also will increases. When the speed is increases after point 2, it is in become that is a non-linear. Okay, it means that the changes of the characteristics. To avoid such thing, it means that its operating range is very low. Only this one. Even the small change in the torque, large change in the power. So for this kind of turbine, it has to withstand that is a heavy load. In case the wind speed is more, the power being generated is dissipated. This is the power being distributed in this way. Yeah, the power being distributed is, the power has to be, the wind power has to be withstand by the turbines. Okay, they dissipated on the loads. Right. The advantage is does not require brushes or clip rings, low maintenance, low cost, simple to operate because of the fixed speed operation, fluctuation in wind speed. Yeah, this is the fluctuation of the wind speed. Yeah, fluctuation in wind speed as well as the gust translate into continuous and sudden torsional torque that stress the drivetrain shaft and gearbox. It has to be withstand. Right. Because of the high speed, the fixed speed wind turbine could be noisy and could cause more bad collisions. And this is, the partial variation of the turbine. Okay, what is the partial variation? Right. So this is the partial variation of the turbine. So how you can control the turbine? See, I told you the purpose of this control is, and control is to limit the speed of the turbine. How I can limit? So here it has been added a resistance. So resistance means you might have done it in the laboratory, the rheostat. So the resistance, when the current is, when you give the more resistance, the current passing through this conductor will be slowed down, and this will convert into heat. So here also, when the power is more, see, when the power generated is more, so then what will happen? I mean, when the wind speed is more, what will happen? The power, whatever the power generation goes through towards to the the resistance. So the resistance means it will generate the heat will dissipate into the atmosphere, right? Such a way that I can limit the speed of the rotors. Okay, I can limit the speed of the rotor. So that is the control of the turbines, or this kind of turbines. That is the variable speed turbine. So what is the variable speed turbine means? When the wind speed is varies, the power also will vary, right? So the wind speed will vary, the power also will vary. So that's why. Then I told you the constant speed turbine, very limited variation only there. But here, this variable speed turbine, even at synchronous speed, below synchronous speed and above synchronous, both wind speeds generating power. It means that the variation we can obtain minus 30 percentage to plus 40 percentage. You can vary the power. The slip percentage. But in the constant speed turbine, only 3 to 5 percentage only. And the opti-slip turbine, the resistance turbine, you can up to increase the 10 percentage. But here the slip percentage is increased minus 30 to plus 40 percentage. It means that wide variation is there. It means that it can accommodate that is a large wind speed, large range of the wind speed, then it can generate the more power compared to the fixed speed wind turbine. So this is, the other type of turbine is called the doubly fed induction generator, DFIG machines. So here the rotor, why it is called the doubly fed is the rotor and as well as the stator also connected to the grid. You see the stator is connected to the grid, and rotor also connected to the grid, you see, through the converter. This is called, that is a power electronic converter, right? So the here up to 40% it can vary. Yes, so you can see here. Yeah, so what is happening there is gearbox, rotor. Here it generate, it generate initially, it drop off from the grid, it gets magnetized. Okay, it will create the electromagnetic force, everything is the same. And here the part of the power is being transferred to the rotor and through the power electronic converter. It means that it convert AC to DC and DC to AC via the capacitors. Right, AC to DC and AC to DC and fed into the rotors. So that's, and some of the turbine without having its partial full scale converter. Whatever the power is being generated is passed through the power electronic converter. Advantage is that is a more efficiency, more higher efficiency. Okay, connected to grid via converters. Wind speed variation generated high pole synchronous generator designed for low speed. That is even at low wind speed it can generate the high power. The grid side converter can independently control active and reactive power. Okay, this is the grid side converter, this is the rotor side converter. The grid side converter can independently control active and reactive power. So that's why the reactive power consumption is less in this one. Okay, it is a gearless turbine. There is no gear in this kind of turbine. There is a direct drive. It the rotor which is directly coupled with the generators. Okay, so the same system only it is there. Yeah, the advantages, disadvantages: can produce power at a low wind speed. Output power can be regulated even when the speed of the turbine changes wildly. Speed of the generator can be adjusted, and lower mechanical stress, noise and bird collision problems are less. And the disadvantage is high cost, more complex system, more components are used that increase the maintenance cost. Right, so that is a double fed induction generator. So I will just explain to you. See here, this is a double fed induction generator. Yes, it's the stator. The stator rotates always at 1000 RPM. Right? Stator field. Yes, the stator field. Yeah. So now the stator, the rotor rotates at 900 RPM, but the stator rotates 1000 RPM. But the difference is 100 RPM. It's a need. But so when it's a synchronous speed means both has to rotate at 1000 RPM. This is the rotor, this is the stator. But here I have the only 900 RPM only. Right now, what will happen? It draws power from the grid. That is the rotor. You can see now feed the power to the grid. So now both will become it taken 100 RPM. Now it will become both 1000 RPM, 1000 RPM. Now it will generate the power. The power goes through the stator to the grid. Right. See now the stator field is that is a constant 1000 RPM. Now the rotor power is more. Okay, now see here. Now the rotor speed is 1100 RPM because my wind speed is more. But stator is still I have the 1000 RPM. Here I have the excess 100 RPM. It means that 100 RPM here now it's rotating in the opposite direction. Now what will happen? Now if it is the excess one, 70% of the power goes through the stator and 30% of the power goes from the stator to the grid. So that is the advantages. So mostly they use the back-to-back converter. So back-to-back converter will be controlled. Okay, so this is the grid side converter. This is the rotor side converter. So it's to control the active and reactive power voltages, and it will control the RPM of the rotors. Right. So these are the control variables: voltage, current, right, and also the grid bus voltage control. These are it's being controlled. Yes, this is the direct drive turbines. Right. Yes, sir. Yeah, I hope I can stop. Otherwise, then I will continue. So, yeah, I would like thank you for attending my class. Then, if you have any question, you may just ask. So, I would like to express my sincere thanks to the management and as well as the organizing committee for inviting me to the lecture. And also, I would like to thank all the participants who have listened my lecture. If you have any question, you may please ask me. Yes, sir. You have any question?
Sir, there is some questions from the participants.
Yeah. Yes, sir.
Okay. Chat box.
Yeah. Somebody has asked, What is the minimum cutoff airspeed?
What is the
Yeah, yes, sir. So it's the minimum wind speed is 3.5 meters per second. 3.5 meter per second. 3 to 3.5 depends on the design. So minimum 3 meter per second. It is required for start generating electricity. And 25 meter per second it will cut off. That is a cut in is 3 meter per second. Cut off is 25 meter per second. Yeah. Then next question is, can you suggest the best manufacturing and fabrication methods of small wind turbine blades? So best manufacturings are many small wind turbine only. Either you can use the different materials by manual, as well as the molding type. You can use the different blades by molding. Different moldings are there. But if you go molding, it will become the costly. You can do it by hand, manufacturing of small wind turbine blades. Yes, sir. Yeah. Any other question apart from this? These are the only two questions I can see here. Any other question from the participant? I hope you understood the basic concept of what I have taken. Any questions?
Participants, please unmute yourself and you can interact with Bhupati garu.
Hello, sir.
Yeah.
Sir, this is Ramakrishna, sir.
Yeah, please.
Sir, can you the 3D printing manufacturing methodology for manufacturing this wind turbine blades, sir?
Yes, sir, we can do it. Yes, definitely we can get it. It doesn't matter.
Okay. So, sir, can we maintain that all the features of that bladings like blade, twist angle, and
Yes,
other
sir,
features
yes, sir.
also? But
yeah. We can make it. We can make it. There is a 3D printing. All the features.
okay. Actually, we are working on the solar updraft tower plant, sir. In that, we have to place that wind turbine blade at the bottom of the chimney. So,
okay.
So if you manufacture that blade with the glass fiber reinforced plastic material, then the weight of that wind turbine blade will be increased. So in order to avoid this, we have chosen that plastic material blades. So which is generally used in the pedestal fans in the homes. So that material we have used. So it is easily running. So but we cannot maintain that blade features like blade twist angles and span length and rotor diameter, whatever it may be. So we are unable to maintain those features. So that's why we are. So that's why we are searching for the best manufacturing.
Yeah, you can do. Yeah, you can do your own. So that's why I told you, you can manufacture by hand. So the small wind turbine, what is the length you need? So accordingly, you can use there is a glass fibers, or you can use other metal like wood and other materials also. You can use it, or combination of wood and glass fibers. You can use it. Depends on the cost, right? So if maybe the length of 1 meter or 2 meter blades, or it will go more than that. What is the length of the blade? Maybe
but
the one
weight
or two.
will be increased, sir. Weight will be increased. But the average speed of that air at the bottom of the chimney is 2.38 meter per second.
No,
so,
that cannot run. That cannot run.
No, that's why what is the solution, sir? Best solution for the speed.
Then if how to reduce the weight means the material. You can. You can make it the thin blades. The same kind of turbine blades, you can make it the thin. So thin structure blades. You can reduce the weight because the 2.8 meter per second, but it can only rotate slowly.
Slowly, sir. Even though it is not moving, sir. With that velocity, that speed, blade will not move.
To extract the chimney.
Yes,
yeah.
So it requires the minimum cutoff speed. More than that 2.3. Yes.
Yeah. So cut in, then you can visit it. The many materials are there, like the carbon fiber, but it's too costly, but more strength, but less weight.
Okay.
Right. Carbon fiber. So it depends on too much cost is high. but the very thin blade you can get it, more strength will be there.
Carbon fiber. Okay, sir.
Yes.
Thank you.
Yeah. Next, is there any
Another
other question?
question from the Jitendra Kumar.
Yes, sir.
Another question from Jitendra Kumar, sir. Plants and trees are resistance or helpful for wind speed?
Which one, sir?
Plants
I'm
and
not-
trees are resist the wind speed or helpful to the wind speed?
It depends where you are keeping your wind turbines. See, when you are placing your wind turbine nearby the trees, it will resist the wind. But generally, it will resist the wind. So the wind is blowing from. It means that it will start from the sea surface, right? It will blow from there. So when it moves through the wind, trees and other thing, it restrict the flow. Okay, sir. It will give obstruction of the wind speed. Yes, sir. Next.
Still any questions from participants? Any questions from the participants?
I hope, sir. Yeah, I hope
Still any questions from the participants?
you may send a mail to me. Yeah. Then I'll be ready to answer your questions. Okay, sir. Thank you. Thank you for listening each and every participant and organizing committee for inviting me to this lecture. Thank you. Yeah.
Thank you, sir. Today we have the nice session. You have given a lot of information regarding the wind turbines and wind energy. So once again, we'll back to you, sir, for phase one. So thank you once again from the college side as well as from the coordinator side. Thank you, sir.
Thank
I
you.
send an email to you. Please go through that one, sir.
Yes, sir. Sure, sir.
So now you can leave, sir.
Yes, sir. Okay, sir. Thank you, sir. Thank you.
So this is the morning session. In the afternoon session, so we have Professor G. Naga Srinivasulu, Associate Professor in the Department of Mechanical Engineering. He is going to give a talk on fuel cell technology, fundamentals and thermodynamic analysis. So all of you join at 2 p.m. So thank you for patiently listening the lectures.
Thank you, sir. Thank you,
We
sir.
are ending the meeting.
Hello.
Sir, good afternoon, sir.
Good afternoon, sir. Sir, is it clear, sir? My
Yeah, clear, sir.
voice and
Yeah, everything is okay, sir.
sir. I'll share the screen just to check it, sir.
Sir, I have to give permission, sir.
Ah, just a minute, sir.
No.
Actually,
Sir,
he has taken the name, my some other name. I'll just leave and I will join again.
okay, sir.